Welcome, my JEE warriors. This is your Captain Shreyas on the number one JEE English channel, which is Vedantu JEE English. And today we are starting with a killer chapter, the circular motion, which is going to lay your foundation for rotational motion. Before this class, we have already done momentum, collision, center of mass, etc. Today, we are focusing particularly on theta, omega, alpha, AC, AT, which is basically circular kinetics. And if you are not aware of these terms, don't worry. After today's class, you will understand it. And if you have heard about it in your school or somewhere else, then today is the time where we scale it up to JEE level. Okay? So it's time, guys, to gather, say hello, subscribe to the channel if you have not yet done that. And once you have subscribed, or if you are already a subscriber, smash that like button down there quickly. Gokul welcome. Hi, Amira Batman. Welcome, Sanjay, Kumba, Abinya, Amira, Week, Panther, Surmai. Welcome, Hema, Deepa. Welcome, everybody out here. I hope I'm audible and visible to all of you. It's time to start this chapter and make sure you're commenting after every single video. Your likes, your attention over here matters to me a lot, because when you attend the lecture sincerely and when you are downloading the PDF after the session is over and going back to your problem books, trust me, you are progressing every single day out there. So make sure this progress never stops, and this consistency is more important than random motivation. So let's begin, and make sure that you're also registered for MVSAT in case you haven't done that. Nice to see you too, Rama. Welcome, King of Kings. Already liked. Very good, Karthik. Hi, Pratyusha. Welcome aboard. And guys, please register for the MVSAT exam. It's very important. The last two dates are here, which is 11th and 12th. You can see MVSAT examination. And this is not only a scholarship exam, but also a ranking exam between thousands and lakhs of students, so that you know where you stand. Individual exams for 11th, 12th, and droppers 9th, 10th, everything. And also lots of prizes to be won, and you get to meet your teachers, and also a lot of content, free resources, and library kits which are given to you once you have registered for the exam. So please register. Last few days, the time is running out. Okay. So that's your MVSAT. Let's begin. Hi Ragul, good evening. Clearly audible. Yes. Thank you so much. Saudamini means a lot, means a lot. Okay. So in the introduction part, we are going to discuss position, displacement, velocity, and acceleration. The moment I say these terms, many kids tell me, Sir, I already know what is position. Position means where you are, and position vector is r bar. It tells me the coordinates of a particle. Sir, displacement, that also I know, sir. I was here, now I am here. How much is my displacement? You just draw a straight line from the initial to the final point. Velocity, how quickly you are moving, right? V. Acceleration, how quickly you are changing that velocity. Sir, I already know this. What are you going to teach them? See this over here. Angular. Angular position. Angular displacement. Angular velocity. Angular acceleration. Oh, the word angular comes. So why is it coming? Because the name of the chapter, what we are studying today, is circular motion. Everything is going round and round like a merry-go round, giant wheel of a truck, or a fan, or a rotating top, or a motor, or you just spinning around, or anything which just rotates. It could be just the moon going around the earth, or just the earth spinning. Anything, doesn't matter. Anything that rotates, spins, revolves, goes around in circular path, that is what we are studying. So that is why angular position, angular displacement, angular velocity, and angular acceleration. The best part is, because you are already familiar with these, understanding this will be very simple. Just that units will change slightly, the symbol will change, and the understanding part is more or less the same. So let's go one by one, starting off with the angular position. Imagine something is going in a circular path. Do you think it is good? It is 1 3, then it is 2 5, then 2 7, then 1 6, 2 3 0 1, like that. If I give you, You're like, okay, there are coordinates, but I'm not getting the feel of it, isn't it? So that is the reason why when we give the position, we give it in a slightly different form. Okay. Uh, Upload the 11th completed videos in the it will come in, it should be there, pro player v, but if it is not, just leave a comment or send me a direct message on my telegram, Captain Shreyas, okay, with a screenshot. I will make sure that it is uploaded. Okay, just send me. So it is beneficial for us to rather give me the position in terms of how far you are from the central axis and what angle are you making with a reference axis. So we define two things over here. One is basically your reference. This is called as your reference axis, reference, reference axis. And this is basically the central axis of rotation, rotation, central axis of rotation. So the particle is going around this center in this circular path. So this is radius. This theta is then called as the angular position. So theta is basically the angle made by your position vector with the reference axis, with reference axis, the angle made by the radius vector with the reference axis, that is called angular position, theta. Obviously it is measured, the SI unit, is radian. The SI unit is radian. Very simple. I am at 5 radian, I am at 2 radian, or pi by 2 radian, pi by 6 radian, pi radian, 3 pi by 2 radian, 2 pi radian. So based on that, I can immediately know where I am. It feels more natural and more convenient. Okay, I'm at 30 degrees, 50 degrees, 70 degrees. So very easy. Oh, I'm there. Oh, I'm here. Oh, I'm here. Oh, I'm here. Okay, and this position R vector tells me how far I am from center. Everybody clear about this? Let me know quickly in the chat box. Okay. All right. Okay, Megasai, where have you commented, my dear? Please tell me again. Maybe I would have missed it because sometimes I might miss, but okay, if you just can tell me, even after this video, you comment your thing, I will reply to today's comment. Okay. So sorry, Megasai, if I missed your comment. Now, the next part is angular displacement. So position tells me where you are. Okay. This entirely told me where you are, how far you are, etc. But angular displacement tells me from here to here you have gone. So how much have you changed your position? So angular displacement has a symbol of delta theta, which is nothing but the change in, delta means change and theta means position angular wise, change in angular change in angular position, change in angular position, that is basically delta theta. So imagine this, right now the angular position is theta I, this is at t is equal to 0. Maybe after some time this particle comes over here, so this becomes my final angular position. Then this particular angle that you see over here, this becomes delta theta, final minus initial. This was your initial angular position. As you can see, this was your initial angular position and this was your final angular position. So if you subtract this angle with this angle, whatever is remaining is the angular displacement. This position is at the current time. This is your current, or your final position. So how much have you moved? That is delta theta. So I can also say it is final angular position minus initial angular position. Very easy peasy lemon squeezy. I'll just block this off. Okay, everybody fine till this point? Shall we do some questions on this? All right, great. Okay, 0.1 like per second. That's the like rate. Thank you so much, King of Kings. So I have a very interesting question, and let's say how many of you get it right. Okay. So what happens is there is a particle which has gone from here to here. Then there is a particle which has completed a circle. There is a particle which has just completed 2 rounds. Maybe like this. I'll show it. Okay. Just observe. I was here initially. Now I am here finally. I have gone like this. I was somewhere here initially. I go around and finally reach the same position. I am somewhere over here initially. I go like this and I switch my track and continue my journey and finally again reach over here after 2 rounds. After 2 rounds. Here there is 1 round. Okay. Here it is basically just half a round. Half a round. If you ask me, what is the displacement, not angular, just displacement? Here in this situation, you can easily see my displacement is this much. My displacement is this much. So displacement will be radius plus radius, which is 2 times the radius. Here, if you ask me, I've come back to the original position. So my displacement is 0. Here, if you ask me, I went 1 round and second round, but final position is equal to initial position. So again, my displacement is a big fat 0. But now let's talk about angular displacement. Angular displacement, which is delta theta. So look over here. I have moved from here to here. So this is the angle which I have covered. Obviously, it's a semicircle. That means 180 degrees. But usually we give it in terms of radian. So we write it as pi radian. So pi radian is the first answer. Everybody, very good. What about the second answer? A lot of students are going to tell me, sir, the answer is 0, but that is exactly where you have made a mistake. It is not 0. In fact, the displacement is final position, which is actually 2 pi radians minus initial position, which is 0 radian. So hence, the answer comes out as 2 pi radian. Although you have displaced 0, but angle wise you have displaced 2 pi radian. That is very, very important. In this scenario, again, your actual displacement is 0, but my angle swept. Think about the angle which has been swept once and twice. So the angle swept is 360 degrees, but into 2 times, which is nothing but 720 degrees or 4 pi radian. 4 pi radian. Is that absolutely clear? When I have just started the class, I think you should be able to catch up. Not to worry. Imagine a situation where a particle starts from here, goes around like this and 2 rounds, and then decides, okay, I have to take a U-turn and it comes over here. Tell me, guys, in this scenario, how much is the angle covered? If you give the answer IIT seat pakka, let me see how many of your IIT seats are pakka, guys. Quickly let me know the answer in the chat box. How much angular displacement is there? How much angular displacement is there? Check this out. From here to here is 1 round. Okay. Then one more round. So basically, you can see that there are 2 rounds. There are 2 rounds which are done like this anti-clockwise. 1 and 2. And then half a round clockwise. And then half a round which is clockwise. So can you now guess what should be the angular displacement? Good evening, IMG. Yes, come on, my dear warriors. 2 rounds means each round is 2 pi radian. So 2 pi into 2. And half a round means pi, which is a semicircle. So minus, because the directions are opposite. So it is 4 pi minus pi, which means it is 3 pi radian. That is the answer. Is that clear? So 3 pi radian is the right answer. Cool, guys. I'm pretty sure You ask this kind of question to many kids, even in 12th standard. Trust me, many kids don't know the simple angular displacement. So this is very, very important where, especially in JEE Advanced, where even the minutest of the minutest concept will matter. Okay. So now let us go on to one more question coming up on your screen. And here it is. It was asked in JEE 2023. A body is moving with constant speed in a circle of radius 10 meter. Body completes one revolution in 4 seconds. At the third second, what is the displacement in meter, not angular displacement in meter? Okay. So let's understand. The body completes one complete circular motion in how many seconds? 4 seconds. So if this is t is equal to 0 seconds, you divide this in quarter. Here it will be at 1 second. Here it will be at t is equal to 2 seconds. Here it will be at t is equal to 3 seconds. And again it will be back over here at t is equal to 4 seconds as it completes the circular motion. Question is, at the end of the third second, what is the displacement? Not angular, just displacement. This will be the displacement, my dear students. This is your displacement. So to find that out, just do a simple geometrical construction like this. Over here, each of this is radius and the radius is given to be 10 meters each. So hence the displacement by Pythagoras theorem will be 10 square plus 10 square, which is 10 root 2 meters. So displacement will be 10 root 2 meters, which is fourth option right over here. If the question was angular displacement, then the answer will be slightly different. This much is the angle covered in the 3 seconds. So this will be delta theta. And in that case, angular displacement will be 270 degrees. You can see that 270 degrees, which is nothing but 3 pi by 2 radian. 3 pi by 2 radian. All right. Perfecto, Rama. Yes, you gave the correct answer. Everybody should spam the answer in the chat box. Very good, guys. Kudos to all of you. Kudos. Now that we have understood this, let's go to the next term, which is angular velocity. Position done, displacement done. Obviously, if I've displaced, I would have taken some time. So to cover the displacement, how much time I took, if I divide that, I will get how fast I'm displacing the angle. So if I consider the path of a particle, let's say it is going like this, okay, and let's say this is the center, so it has displaced this much delta theta, and here the time was some t, and here it is t plus delta t plus some delta t. So delta theta angle is displaced in a time of delta t. So in a time of delta t, which is the time interval, you have moved this much. Then I will write down the angular velocity. So angular velocity is in the direction of angular displacement. The symbol for that is omega. The symbol for that is omega, not v. That angular velocity is how much is the angle displaced? Angle displaced. How much is the angle displaced? Whole thing divided by the time which has been taken, upon the time which has been taken. So omega will be delta theta divided by delta t. The SI unit of angular velocity, you can see radian is on the top. It's also SI unit, seconds. So radian per second will be the SI unit. One thing though, this is not just any random omega. This is actually the average angular velocity. So this is basically your average angular velocity. Average angular velocity. Average angular velocity. So triangular brackets. This is the answer for it. Delta theta by delta t. Can you guess What might be the formula if it was instantaneous angular velocity? Because my angle might be different at different times. So maybe my speed is changing. So in that case, what do you think it should be? What do you think it should be if it was instantaneous? Yes. Physics NCRT is definitely not the best, my dear. Okay. Yes. Kavin Raja got 211 All India rank 11. I don't know. Oh. Kavin Raja, why don't you put up your doubt after the session is over? I'll definitely help you out. Okay. So, what do you think, guys? Yes, it should be nothing but for instantaneous. For for instantaneous. For instantaneous angular velocity, it will no longer be delta, it will be just d theta by dt. Dt is a very small interval of time, and in that small interval, I will move small angle. So that is why it will be d theta by dt. That will be my instantaneous angular velocity. Very, very similar to linear velocity. V is delta x by delta t. Instantaneous will be dx by dt. Very, very similar. Is there any relation between circular and helical? In fact, a helix is formed when you take a circular motion and you move that circular motion along the axis of the circle, which you might have seen in magnetism, the charge being thrown at an angle with the magnetic field. So there is a circular motion and you move it along the axis. So the radius of the helix is same as the radius of the circular motion. Okay, so that is the only part which is common. Like in one perspective, the helical motion just looks circular, but in 3 dimension, it looks as if you are moving ahead along with, the circular motion. All right. Having said that, what is angular acceleration then? Say, for example, again, I am here and then I go over here. And in this duration, what happens is at this particular point, I have some angular velocity, let's say omega. By the time I reach here, my angular velocity changes by delta omega. And all of this happens. So, angular velocity changes, angular velocity changes by delta omega in a time of delta t. So maybe 2-3 seconds, it changes by some few radians per second. Earlier I was moving slowly, I become fast, or I was moving fast and it becomes slow. Anything can happen. So then if my angular velocity changes like that, then I can say my average angular acceleration, average angular acceleration is nothing but how much is my change in angular velocity, change in angular velocity upon the time which I have taken. Upon the time which I have taken. How quickly you are changing the angular velocity. That's all. So the change in the angular velocity is delta omega. The time taken is delta t. Change is delta omega, time is delta t. Average angular acceleration. So first of all, average means triangular brackets. The symbol for acceleration in angles is alpha. So alpha is the symbol for acceleration in angular wise or angular sense. Okay. I hope this is absolutely clear. Thank you. Premlata means a lot, my dear. And I'm so glad, Satya, you're loving this channel and welcome to the channel. Keep watching, keep learning, keep improving. And every day that you watch this channel, you're getting one step closer to 99.99 percentile, not just 99. Okay, because the content is of top-notch quality level. Okay, so let me block this. Can we guess the SI unit of this particular term? The SI unit, think about it. This is radian per second divided by second. So radian per second square, just like we had meter per second square. So this is radian per second square. If this was average, what could be instantaneous? What could be instantaneous angular acceleration? Meaning, in a very small interval, at that moment, how much is my velocity changing per unit time? So that is instantaneous. So that would be d omega by dt. That would be d omega by dt. Just like A is dv by dt and average is delta v by delta t. Same things over here in circular motion. Okay. Welcome, Nikhilan. Vijay Lakshmi. Oh, maybe you are watching from some other uh, phone. How angular velocity is equal to frequency in dimensionally? Uh, because radian is a special unit which has no dimension. Remember, there are physical quantities which have units, but they don't have dimension. Which are those quantities? The two auxiliary units, radian, stadian, right? Solid angle, plane angle. So radian is a dimensionless number. So whether it is omega or whether it is alpha, dimensions wise it is same, but unit wise it is different. Just because two quantities have same dimension does not mean they represent same physical quantity. Like torque and work have same dimensions, but they mean completely different. One is a vector, one is a scalar. So, dimensions being same is just happen. It just is there. But you don't have to take it so seriously. All right. So I think now it's a good time to compare both of them together. Position in linear motion. Here we have angular position, and then change in position is displacement. Here change in position is angular displacement. Velocity in linear motion, which is dx by dt. Here in circular motion, you have d theta by dt, which is omega. And acceleration in linear motion is dv by dt, but in angular sense, it is alpha, which is d omega by dt. Very simple and straightforward. So you might be wondering, are they all similar in almost every sense? The answer is yes. So just like if you take position, you can differentiate it and get velocity, and from velocity you can get acceleration. Same way, if you have theta, you can differentiate it and get omega, and again differentiate omega to get acceleration angular wise. So everything is similar. That's what you're going to see, and that is what we are going to solve right now. Okay, let's look at some questions coming up on your screen. Here it comes. There is one thing though which I wanted to mention in angular velocity, and that is something called frequency. It's free. You can say frequency or rounds per minute. Sometimes you might say that the unit used is not radian per second, rather it could be RPM or hertz or something like that. Okay, so what to do in that case? Say for example, anything is given in RPM. Anything is given in some X RPM, 5 RPM. RPM means how many rounds are you performing per, P for per minute, rounds per minute. So let's say I am performing, Chumma, I'm giving you some example, 300 RPM. My fan is rotating 300 rounds every single minute. Now keep one thing in mind. One complete round, okay, one complete round, one round is how many radians? It's 360 degrees, which is nothing but 2 pi radian. Also, 1 minute is how many seconds? It is nothing but 60 seconds. Just use that fact over here. That's it. So, whatever RPM you have, what you do, every round is 2 pi radians. So, that particular number which you have, 300, multiply it by 2 pi. So, if I'm doing 300 rounds, each round is 2 pi radian. So, 2 pi, 2 pi, 2 pi, 2 pi, 300 times. That many radians I have covered. But it is per minute. That means I have to divide it by a minute, but a minute is nothing but 60 seconds. So finally, whatever answer you get will be in radian per second. That's it. That is the conversion factor between RPM and radians per second. Many times you are going to see this. So in this case, the final answer will be 60 goes with 305 times, 5 2s are 10. So it will be nothing but 10 pi, 10 pi, and this will be radians per second. So the answer will be 10 pi radians per second. Got it, my dear students, how to get the conversion between RPM and your radians per second. Correct. Rounds, revolutions, whatever you want to call it. Now, you can do the reverse also. Say, for example, Chumba, another example I'm giving. Say the rounds per minute are 25, sorry, not rounds per minute, radians per second are 25 pi, 25 pi radians per second. Can I convert this into RPM? The answer is yes. All you need to do is now multiply this with 60 and divide it by 2 pi. So if you want to convert from radian per second into rounds per minute, divide by 2 pi and multiply by 60. Exactly opposite. And see what you get basically. 60 by 2 is 30. 30 into 25. Well, 325, that's 75. So one more zero. And that pi and pi will also cancel. So 750 RPM. That is the answer. So you can do the exact reverse calculation also. Cool, guys. Understood this conversion? Now, there is one more conversion which you should be aware of, and that is frequency. How many rounds are you performing per second? Frequency is also a very familiar thing which you should be aware of. So, frequency, frequency, frequency is basically number of rounds, number of rounds that you perform per unit time, number of rounds that you perform per unit time. So that symbol is basically F, that symbol is basically F, and if you know the frequency, you can easily get omega also. If you know the frequency, you can easily get the omega value also. The unit of frequency, the unit, the unit, the unit of the frequency is, look at it, rounds, it is unitless, time is per second. So it is basically 1 by second, which is called as hertz. The short form is just Hz. The short form is just Hz. So 1 by second is the unit of frequency, which is actually called hertz. So let's do a conversion and understand it. Say, for example, I have been told that my particle is revolving at maybe 40 hertz. 40 hertz is given. 40 hertz is given. So 40 hertz means it is revolving 40 times in 1 second. So how many rounds would it have covered in 1 second? 40 rounds. And each round, do not forget, is nothing but 2 pi radian. Each round is nothing but 2 pi radian. So how many radians did it cover in 1 second? 40 multiplied by 2 pi. So that many radians it has covered per second. So you have converted it into omega. That's it. So hence the answer in radian per second, the answer in radian per second, 42 is 80. It will be 80 pi radian per second. So very simple, guys. What is the final relationship? If you want to find omega, right? If you want to find omega, take your frequency and multiply it by 2 pi. So 2 pi multiplied by f. That is the answer. Can you see? Omega, which is 80 pi, will be 2 pi into f. F is hertz. Very simple and straightforward. Great. I hope this is absolutely clear. Just go through these slides. Very important, my dear students. Okay. Very, very, very important. So I'll just block this off for all of you. Omega is 2 pi f. This is one thing. And of course, conversion factor. Okay. Now it's a good time that we can solve some questions on this and see what do we get. Okay. So there is a fan which rotates at 100 RPM and increases the speed to 700 RPM in 2 minutes. Find angular acceleration. Find angular acceleration. That is the question. Okay. Let's do this. Find the angular acceleration. To find angular acceleration, what do we need? If you go back, you'll realize we'll need change in the angular velocity upon time taken. Time taken is given, change in angular velocity is asked. So let's go back over here. So if I want to find my angular acceleration, I will need the change in angular velocity and divide it by the time. So it will be final omega minus initial omega upon the time which has been taken. Now, one thing though, the omegas are not given in radian per second, and we have to give the answer always in radian per second unless asked otherwise. So we have to do that conversion part first. Okay. So 100 RPM means I have to take that number 100 multiplied by 2 pi radians, and it is per minute, so divided by 60 seconds. Same thing over here also. So 700 I will multiply it by 2 pi radians and then divided by 60 seconds. The time taken is 2 minutes. So 2 minutes means 2 into 60 seconds. So many things are there. So let's start substituting now. Okay, so velocity, final velocity is 700 multiplied by 2 pi divided by 60 minus initial is 100 multiplied by 2 pi divided by 60 whole thing divided by the time period. Time period is nothing but 2 multiplied by 60 right over here. Okay, so 700 minus 100 is nothing but 600. So 600 multiplied by 2 pi divided by 60, whole thing divided by 2 multiplied by 60. Now this 60 and 600 will cancel, only 10 will be remaining. So on the top, we will just have 20 pi and the whole thing divided by, I hope you got it, 60 and 600 will go 10 times, 10 into 2, 20. And bottom, we just will have 120. Now 20 goes with 120 6 times. So this will become pi by 6. But be careful, the unit will be radian per second square. So pi by 6 radian per second square is the final answer. Is that clear, everyone? Awesome. Great, great. Okay, William Joshua, hold on. Don't give up so easily. I know you don't have holidays, you don't have time. Maybe I should make a video now on how to manage this difficult phase, because I don't want my students to give up so easily, because you are very close to achieving your target. Just have to have a little bit of patience. I know it feels like you have to give up, but trust me, you can do it. Okay. Yeah, no issues, Rama. Happens. Mistakes. Okay, let's go to the next question coming up on your screen. There is a particle, there is a particle that performs 20 rounds in 4 seconds. Find omega and frequency, both. Find omega as well as the frequency of the particle. So let's try this out. It has done 20 rounds in 4 seconds. Okay. So if it does 20 rounds in 4 seconds, in 1 second, how many rounds will it do? Obviously, 20 divided by 4, which is nothing but 5 rounds. It will do 5 rounds in 1 second. But 1 round is 2 pi radians. So 5 rounds is 5 into 2 pi radians. It is doing in 1 second. So therefore, quickly we can write omega will be 5 into 2 pi radians. It is doing per second, which is nothing but 10 pi radian per second. Very easy and straightforward. Once I get omega, we can also find frequency. I just gave you the formula. Omega is 2 pi into f. So omega is nothing but 10 pi. Here we have 2 pi. So therefore, f will be 10 pi by 2 pi. Pi goes, 10 by 2 is 5. So 5 hertz is the answer. So the frequency is 5 hertz. How fast it is rotating per second. And second part, omega, angular speed is 10 pi radians per second. Cool. Let's go to the next question on your screen. If the angular position is given by 2t cube minus 4, find omega average for first 2 seconds and omega instantaneous at t is equal to 2 seconds. Completely different questions, but based on the same data. Find average angular velocity and instantaneous velocity till 2 seconds and at 2 seconds. Whenever instantaneous is asked, it will be at a point or at some instant. Whenever average is asked, it will be for a duration. Okay, for some interval. It will never be at a time. What is this average? Because average means an interval, instantaneous means a point, a singular point. Okay, so how do we do this? Let's try this out, my dear students. Okay, so first of all, I think if theta is given, if I have to find instantaneous, I just told you about the derivative formula, right? Over here. Omega is d theta by dt. I just told you about it over here. Omega is instantaneous is d theta by dt. Average is delta theta by delta t. Okay. So let's do one thing. I think we can easily find omega instantaneous, which is nothing but d theta by dt. So that means I just have to put the value of theta over here, which is 2t cube minus 4. Now I have to just take the derivative. So 2 into derivative of t cube minus there is derivative of that number 4 with respect to time. So this will be nothing but t cube's derivative is 3t square. Derivative of a constant is 0. So hence it will be 6t square is the angular velocity. But I want at a very specific time, and that is 2 seconds. So if I want to find omega at 2 seconds, it will be 6. Substitute the value of time as 2. So 2 square. So it will be 6 multiplied by 4. Therefore, angular velocity will be 24 radians per second. That is this particular answer. Okay. So we got the angular velocity at a instant. At an instant. Now let's focus on average angular velocity. For that, I will need displacement. How do I find displacement? I have an idea. How about finding what is the initial position when time is 0? Substitute time as 0. You will get 2 multiplied by 0 cube minus 4. So it will be nothing but minus 4 radian. Then find the position at 2 seconds. That means put the value of time as 2 and then see what is the answer. 2 cube is 8, 8 to the 16, 16 minus 4 is 12. So 12 radian. So the angular displacement in 2 seconds is final minus initial, which is 12 minus minus 4, which is basically 16, radians. So now we can find the average angular velocity in that 2 seconds. which will be the displacement upon the time interval. The displacement is 16, time interval is 2, hence the answer will be 8 radian per second. That is the answer. Very easily we got it. Yeah, average is 16 by 2, which is 8, not 6. It will be 8. So both the answers are different. The methods are also different. So we'll have to use our brains to solve these kind of questions. Okay. So let's go to the next question, guys, coming up on your screen. And here it is. What is it? If omega is 4t square plus t, then find alpha at t is equal to, let's say, 3 seconds and average alpha till 3 seconds. Very similar to the previous one, but alpha is asked, which is average and instantaneous angular accelerations. Okay, let's try it out. If I want to find instantaneous from omega, just think I have to calculate acceleration from velocity. I have to calculate acceleration from velocity instantaneous. So it's nothing but simple derivatives. But for average, it will be delta. It is a change. It is not exactly derivatives. Okay. So go back over here and let's see what can we do. Alpha instantaneous will be d omega by dt, isn't it? Alpha will be d omega by dt. Okay. So substitute. What is the value of omega over here? It is nothing but 4t square plus t. Okay, let's split up the derivatives. The number 4 is a constant, goes outside. Derivative of the number t square, okay, plus derivative of just t over here. So derivative of t square is 2t and derivative of dt with respect to t will be just 1. So hence alpha will be 8t plus 1. That is in general, but I want very specifically at 3 seconds. So alpha at 3 seconds will be 8 multiplied by 3 plus 1. 8 3s are 24, 24 plus 1 is 25. So therefore alpha 3 will be 25, but this will be radian per second square. Very similar to the previous one. Okay, it was derivative here also and here also. Cool. Everybody, till this point, absolutely clear. Very good, Rama. Very good image. Excellent. Pro player, you can get in touch with me on Instagram also. Captain Shreyas, again, same Instagram handle, or just put up a comment regarding the issue you are facing below this video. Me and my team will get back to you. Okay, or else Telegram. Yeah, right. Now, imagine I want to find average acceleration. So average acceleration means I need the change in the velocity. I know the velocity, I need to find the change. So can I figure out what is my initial angular velocity? First put time as 0. So it will be 4 multiplied by 0 square plus 0. So it will be 0 radians per second. That means I was at rest. What is my final angular velocity? Substitute time as what is it? 3 seconds. So 3 square plus 3. 3 square is 9. 9 fours are 36. 36 plus 3, 39. So 39 radians per second. Time interval I know. So average alpha will be final minus initial upon the time interval. Final is 39, initial is 0, time interval is 3. So 39 by 3 is 13 radian per second square. That was average. This is instantaneous. Clear, guys? Very good. Mashpaku Poo Akshay, very good. Yes, Rama, perfecto. Got it. Amazing. Let's do the next killer question coming up on your screen. Slowly, you are getting a perfect hang of it. If theta is t raised to 4 minus 16t plus 5. Find omega and alpha, number 1. Also find when is omega 0. Find when is omega 0. That is the question. Let's try this out. First, let's analyze what is given and then let's go to what is asked. Theta is given, omega and alpha is asked. If position is given, velocity and acceleration are asked, it's obvious I have to take the derivative considering it is instantaneous. Okay. So for omega, it's very straightforward that I will have to take the derivative of theta with respect to time. So it is the derivative of t raised to 4 separate minus 16 derivative of time separate. I'm just simplifying, just skipping one step rather, just taking the derivative of it because plus and minus is there. I can take separate derivatives over here. Okay, so this will be 4t cube minus 16 into 1 plus derivative of a constant is 0. So it will become 4t cube minus 16. That's it. That is your omega. Once I get omega, we can also find what is alpha because alpha will be d omega by dt. That means take the derivative of 4 which is outside and t cube's derivative minus derivative of that number 16. So 4 is as it is, derivative of t cube is 3t square, constant's derivative is 0, 4 3s are 12, so 12t square is alpha. So we have found omega, we have also found alpha. What now? We have to find when is omega 0. So to solve this particular part, I will substitute the value of omega as 0 and see what do I get. So 4t cube minus 16 is 0. Therefore, 4t cube is 16. Therefore, t cube is 16 by 4, which is 4. So therefore, t will be cube root of 4. So at this time, cube root of 4, you will see that instantaneous angular velocity will be 0. That's it. I just have to substitute omega is 0 and I get the answer. Plain and simple. Everyone, cool? Shall we proceed ahead? Shall we proceed ahead, my dear students? Let's see the next question coming up on your screen. This is time. This is angular velocity. Let's say some random graph is given, okay, and it's angular velocity versus time. The question asked is as follows: find the total angular displacement. What is the average angular speed? Average angular speed. What is the angular acceleration between 0 to 5 seconds? What is the angular acceleration between 9 to 10 seconds? Okay, these are the 4 questions which are asked. Let's see whether you can figure it out. Okay, these are the 4 questions which are asked: angular acceleration, angular velocity, and so many things. So let's solve it one by one. You might be like, sir, graph, how to solve these kind of questions? I'll tell you what, forget that the word angular is used. Just treat it like a normal linear motion problem. How you would solve velocity time graph problem? Just solve it exactly like that. So think like this, that total displacement is asked. So if velocity time graph is given, how do you find displacement? Exactly, you guys nailed it, guys. If you have told area under the curve, so angular displacement is nothing but the area under omega versus time graph. So you just have to find that area, nothing else. So first of all, if you see this particular thing and then this particular thing, what are those areas? Let's see. This is a triangle, so half into the base, which is 9, multiplied by the height, which is 10. So 9 by 2 is 4.5. So 4.5 into 10 is 45. So this will be 45. This will be again half into base. Base is 9 to 14. So which is 5, multiplied by the height, which is basically 8. 8 by 2 is 4. 4 5s are 20. So this is 20. So what is the area under that entire curve? You will say 45 and that 20 and you will add it. That is wrong. Subtract it because this area is below the horizontal graph. So that's why it is negative. Hence, this is nothing but 25 radian. This is very, very important. This is the angular displacement. So first part is done. First part is done. Everyone clear? Okay. Next is angular velocity. That is also straightforward. Angular velocity, average. So average angular velocity is nothing but how much angle you have covered upon the time taken. Angle covered is 25. Time taken is that entire time. So 25 by 4 radian per second. That part is also done. Okay. So that part also we did it. Now angular acceleration between some time intervals is asked. So first is 0 to 5. So if you look at 0 to 5 graph, my initial velocity was this much, final velocity was this much. So I know how much is my change, and this is the time interval that I'm talking about. This is the time interval that I'm talking about. So for the first part, alpha will be the change in the velocity upon the time taken. Final is 10, initial is 0, time taken is 5, hence alpha will be 2 radian per second square. So this part also done. Okay, change is 10 minus 0, time taken is 5 seconds. Great, perfecto. All right. What about the last part, which is this one here? This is final, this is initial. At 9 seconds, my velocity was this much. Finally, my velocity was this much. I have changed from here to here. This is initial, this is final. So alpha, which is final minus initial divided by that time. Final will be basically minus 8. Initial will be 0. Time taken is barely 1 second. So hence it will be minus 8 radian per second square. That's it. So graphical questions also you can do. It's very, very straightforward. Cool. So how many of you are feeling, sir, I had done 1D motion properly or I remember many concepts. That is why this is looking very easy for me. It's nothing great. It's the same thing. In fact, I'll tell you one more thing. If you're finding it simple, even the kinematic equations are valid. Yes. Even the kinematic equations, V is U plus AT, S is UT plus half AT square, V square is U square plus 2S, that also you can use. Just that the symbols have changed. Final angular velocity is initial angular velocity plus angular acceleration into time. Angular displacement is initial angular velocity into time plus half angular acceleration into time square. And final angular velocity square is initial angular velocity square plus 2 into angular acceleration into angular displacement. All the kinematic equations are valid as long as my angular acceleration alpha remains constant. Yeah, I hope this is clear. This is not one shot. This is lecture by lecture, but our lectures are not like 45 minutes or 30 minutes or even 1 hour. Our lectures are around 1.5 hours to 2.5 hours. And we divide the chapter into segments. Okay, part 1, part 2, part 3. Okay, which we can go together. Right? Okay, Nakul, I hope this is clear. Today we are just doing kinematics. All right. So let's do some questions on the kinematics part. Imagine it is given to me that a fan rotating at 600 rpm stops in stops in 10 seconds. Find alpha and angular displacement, also the number of rotations till it stops. Till it stops. Okay, very simple, straightforward question. Let's analyze whatever is given to me first. A fan is rotating at 600 rpm. That means I know my initial angular velocity. So that is 600, but in rpm, I don't like that rpm. I will multiply it by 2 pi and divide it by 60. So 60 and 600 goes 10. 10 into 2, 20. So 20 pi radian per second. Finally, it is coming to a halt. The time taken to stop is given to be 10 seconds. If I have to find alpha first, the obvious choice of equation will be which one? My final velocity will be initial velocity plus acceleration into time, the first kinematic equation. Final velocity 0, initial velocity is how much? 20 pi. Initial velocity is 20 pi. Alpha, I do not know. Time interval is 10 seconds. So therefore, 10 alpha will be 20 pi, but this will be with a minus sign. Therefore, alpha will be minus 2 pi radian per second square. Minus 2 pi radian per second square. Is that absolutely clear? How we got alpha is minus 2 pi radians per second square? Great. Next. We have to also find delta theta. How do I find delta theta? Well, I can use S is ut plus half at square, all right? Or I can also use v square is u square plus 2s, anything. So I think let's just go with this. Displacement is ut plus half a t square. Initial velocity, where is it? 25. Okay. Time 10 plus alpha is negative because it is retardation, and time is basically 10. So put 10 square over here. So what do we get? 20 into 10 is 200. So 200 pi. 2 cancels, minus 10 square is 100. So minus 100 pi. So this will be just 100 pi radian. So we got delta theta also. First part is done. Let's go to the second. Hi JD Creations, welcome aboard. How many rotations will it take to stop? If these are the number of radians it has covered till it stopped, these radians will be the number of rounds, and each round will have 2 pi radians. So therefore, the number of rounds will be 100 pi and each round will be 2 pi. So that is how I'll get the number of rounds, which is nothing but 50 revolutions. So it will revolve 50 times before it stops. That is the answer. Again, we have used just simple kinematic equations. Okay, everyone? So kinematic equations are still valid. You can just keep on doing as many problems as you want. Like we'll do one more just so that you get full confidence. Okay. If a motor is revolving at 50 pi radians per second and and in 100 pi radians increases the speed to increases the speed to 250 pi radian per second, or let's say 150 pi radian per second. Find alpha. Find angular acceleration. That is the question. Let's try this out. Whatever is given, let's write it down. First of all, this is nothing but initial velocity. Increases the speed to this much. This is nothing but final velocity. It takes 100 pi radians. That means this is the angular displacement. What is asked is alpha. Which kinematic equation are you going to use? Think. Final velocity, initial velocity, displacement, acceleration is asked. The third kinematic equation, yes, final velocity square is initial velocity square plus 2 alpha delta theta. Final velocity is 150 pi whole square. Initial is 50 pi, that whole square, plus 2 into alpha, I do not know. Angular displacement is 100 pi. Okay, so 15 square is 225, but two more zeros and this pi square. 5 square is 25 and two more zeros with that pi square, plus 100 into 2 is 200, a pi and alpha. A lot of things will definitely get cancelled, like this 0, this 0, this 0, this 0, this 0, this 0. This pi square and this pi square, single pi will still remain. That's it. Okay, perfect. So I have 225. Take this 25 over here. 225 pi minus 25 pi is equal to, I have 2 alpha. 225 minus 25 is 200. So 200 pi is 2 alpha. So alpha will be this by 2. Therefore, alpha will be 100 pi radian per second square. That is the answer. 100 pi. Everyone, very good. Keep it up. Yes, come on, guys. Make the likes to number of 100. Yeah, people are chumma voting. Yes, I have liked the video. Who are cheating, man? Go, I can see it over there. Quickly smash that like button down there right away, right now. Yes. Okay. Cool. Amazing. Amazing. So, as you can see, kinematic equations are valid. Graphical approach is valid. Okay. Derivatives, integration, whatever you have learned in kinematics are all valid over here. Okay. We have just seen that. Now, let's take it a bit further ahead. Okay. Now we are going to go to some relationships between velocity and angular velocity and all of that. And that will, give us some more understanding of circular motion. Remember, today we are not talking about masses. We are not talking about forces. We are just focusing on accelerations, velocities, and displacements. Nothing else. Nothing else. Okay. Now, let's talk about linear displacement, linear distance, sorry, and your angular displacement. How are they related? Say, for example, one particle goes from here to here. It has covered the length of an arc, but displacement angular wise, it is theta or delta theta. Are they two related to each other? Yes. We all know that the length of an arc is nothing but the radius multiplied by the angle subtended. Angle subtended. Yes, the length, if it is in meters, radius should be also in meters, and angle subtended, that should be in radians. This is a standard thing in trigonometry which you have learned. So the length of the arc is nothing but the distance which you have traveled. Okay, this is the distance that you have traveled. Radius is whatever that r is. And of course, the angular displacement, which is delta theta, which is nothing but delta theta. Is nothing but delta theta. That's it. So this is very simple. The relationship between the distance traveled, not the displacement. This is distance, and this is angular displacement. Angular displacement. Angular displacement. Let's. We want to find just the displacement. Then please remember, just displacement will be the chord. Yes, if displacement is asked, the normal displacement, not angular displacement, just the displacement is asked, it will be nothing but the length of the chord, which is not the length of the arc for large angles, which is not the length of the arc for large angles. Is that right? Because arc length will be more, chord length will be less. So this is nothing but your displacement vector. This is nothing but from initial to final, that is displacement. That is completely different thing. That you can use simple trigonometry and get the answer. It is not that difficult. Okay. That is nothing but trigonometry over here. If you want, I can do it. It's not a big deal. See guys, the angle is delta theta. You have to find the third side. Actually, there is cos rule in your trigonometry, if you remember. Yes, cosine rule. There is sine rule. Similarly, you have cos rule. So what does the cos rule say? Let's say this is side C. C square is a square plus b square plus 2ab cos theta. Just use the cos rule, nothing else. Just have to use the cos rule. So basically, that displacement S will be r square plus 2r multiplied by cos delta theta. It's the cosine rule which I've used. Cosine rule in trigonometry. Cosine rule. Okay. But remember one thing, this is not plus, it is actually minus. Okay. Minus 2r. So what will this become? You can, oh, by the way, this is also squared. Okay. So r square plus r square is 2r square. Here also you get 2r square. So we will get 2r square common. 1 minus cos delta theta. That is basically s square. Therefore, s will be r root of 2 into 1 minus cos delta theta. So this can be used as a formula, or you can use cosine rule, sine rule, whatever, and get the displacement. This is at the end of the day trigonometry. At the end of the day trigonometry. Okay? Everybody clear about this? Pakka? Yes? No? Let me know quickly in the chat box. Have you studied cosine rule? Do you know the cosine rule? All of that. Okay. So there is a minus sign. I by mistakenly said plus initially. It is minus. Okay. Right. That is the first thing. Second thing, what is the relation between angular speed and linear speed? Length and angle. Distance and angle we got to know. Displacement and distance or angle also we got to know. If you want, you can remember this. It's not mandatory. Okay. If you want to save time, yes, it is always better that you know this formula. Okay. Now, angular velocity and velocity. It's very simple, guys. I'll tell you what. If the length of the arc covered is this much and the radius is r, angular displacement is delta theta. What happens if I divide this with time and this also right hand side with time? What are you going to get? Length by time. How much distance I'm covering per unit time? That's your velocity, normal velocity. This is r, and this is nothing but your angular velocity. That's it. V is r omega. Very simple and straightforward. Velocity is r into omega. And I will make you visualize this. How V is r omega. Let's take the example of a fan. Everybody might have seen a fan rotating in your house on the ceiling. This is the blade of the fan. Now, I'm not drawing the other blades, just visualize it. Imagine that fan is rotating with some angular velocity. And I consider a couple of points like this point here, and maybe this point here, and this point here. This is point 1, 2, 3, and 4. If I ask you, compare their velocities and compare their angular velocities, what will be your answer? Hi Bharadwaj, good evening. Compare the velocities and angular velocities, what will be your answer? See, every single point will move the same angle in same time. Don't believe me? Observe it like this. After some time, you know, this would have moved this angle, this angle, this angle. This is a point. It has rotated by that angle. So all of them have rotated by the same angle in the same time. So actually speaking, omega is the same. Omega is the same because delta theta is the same. All of them have same angular velocity. Lot of people think, sir, 4 has more speed, 3 has less speed, etc. That is wrong. Next, what about linear velocity? V is R omega. Omega is same, so the one which has more R will also have more velocity. So as you can see, R is the highest for number 4. So it will have the highest linear velocity. Then this will be less, and this R is 0, so no velocity. So V4 will be more than V3, which is more than V2, which is more than V1, but V1 will be 0. V1 will be 0. So the extreme points will be having very large speed. The points closer to the axis will have smaller speeds. Okay, got it? So that is what this relationship means. The farther you are, the more speed you are having linearly. But angle wise, you will be covering the same angle on that same body. How many of you got this? How many of you are able to visualize this? It's a very good example to explain this formula. Yes, perfecto. Okay. But I'll tell you one thing, there is also vector rule to remember it, for you to remember. If we do not remember it as R omega, actually it is omega cross R. If you treat omega as a vector quantity and R as a vector quantity. So I'll tell you what exactly happens. So even when I gave you omega over here, sometimes kids ask me, sir, is angular velocity a vector or a scalar? The answer is omega is actually a vector quantity. Yes, omega is basically a vector quantity. And how do I know what direction it is? It's straightforward. If I am rotating like this, okay, wait a minute, just draw it. Observe this now. I've just shown some rotating bodies, and I'll tell you what is the manner in which you can find the direction of omega. Omega is a vector quantity. How to find the direction of omega? Observe. If something is revolving, rotating, spinning, take the 4 fingers of your right hand, not left hand, right hand, and try to curl your fingers in the sense of rotation. Like if I take my 4 fingers, I can see it is rotating like this. Then the thumb points in the direction of omega. The thumb will point in the direction of omega vector. Actually, omega vector will always be perpendicular to the plane of rotation. If this is the plane of rotation, omega vector will be perpendicular to that plane. Now don't think, sir, what nonsense, it is rotating like this and you're saying omega is like that. Nonsense is that. See, the thing is, whenever things are rotating, you will see right hand thumb rule. Number two, why we need that thumb and that right hand rule and all of that? If I am rotating something, for you it is clockwise, for me it is anti-clockwise, there is a confusion. But imagine I give you omega as a vector, there will be no confusion at all. How? I'll tell you. Imagine I tell you omega is in the direction of negative x-axis. Negative x. This is positive x, this is negative x. So omega is towards your left side. So hold the thumb like this. Automatically your fingers will curl like that. You will understand that the object is rotating like this. So omega just represents a vector which helps me understand the sense of rotation. It's not actually going in that direction. That is a wrong thing to interpret. Nothing actually goes in the direction of omega. It is just a representing vector to help me figure out the sense of rotation. So if I know omega vector is like this, I know if I hold my thumb in this direction, my curls of the right hand fingers will be in this direction. If my fingers are rotating like this, then the thumb goes down. So my omega vector will be downwards. So this is how omega is treated like a vector quantity. Is that clear, everyone? Hi, Vinitra. Good evening, everyone. So now going back to that particular slide where we had to treat it like a vector quantity. Here we go. Velocity is omega cross r. As you can see in that purple shaded diagram, the object is revolving like this. Take the fingers of your right hand, curl it like this. Can you see omega vector is up? Okay, so omega vector is up. My particle is here, so the position vector is like that. Omega cross r gives me actual velocity. Makes sense? Because see, if omega is a vector which is upwards here, this is my omega, cross r vector. Cross r vector is here, r vector is here, okay, omega cross r, I will get my linear velocity which is in this direction. Can you see omega cross r goes inside, it is like this. So this is the direction of my velocity as well. You can see this is actually omega cross r vector. Omega cross r vector is in this direction, which is the same as the direction of your velocity, which is the same as the direction of your velocity. Is this absolutely clear, everyone? How this has to be used? V is omega cross r, not r cross omega, omega cross r, right? Perfect. Cool. So I think we can solve some questions maybe over here. This was asked in JEE 2023. Okay. A clock has some length. Okay. Second hand, minute hand, respectively, in 13 minutes duration, the tip of the second hand will travel X distance more than the tip of the minute hand. I think it's based on the length of the arc concept. Okay. Let's think about it. See, guys, 75 centimeters and 60 centimeters, second hand and minute hand. Okay. So this one long second hand and long. This is second hand. In 30 minutes, how much will the tip travel? So if you are considering the tip and how much distance it is traveling, that length will be r into theta, r into the angle which you would have displaced. Now we are talking about the second hand. The second hand, think guys, in 30 minutes, in basically 30 minutes, every minute it covers one revolution or 2 pi radians. So in 30 minutes there will be 30 revolutions for the second hand. Each revolution is 30 into 2 pi, sorry, it is 2 pi radians. So 30 into 2 pi radians it would have covered. So I got the angular displacement. I got the angular displacement. Why did I put 2? My bad. It was r multiplied by angular displacement. Okay. So what is the radius? The radius is 75 centimeters. What is the angle? It is 30 multiplied by 2 pi. See if you understood it. Okay. In 30 minutes, second hand will move, in 1 minute, 1 rotation. So 30 minutes, 30 revolutions. Each revolution is 2 pi radian. So that many radians it has covered. Next important thing, length of the arc by the tip, which it would have moved distance wise, is r into theta. So radius is 75 into angular displacement. Now do the same thing for the minute hand. In 30 minutes, the minute hand would have done just half a revolution. And half a revolution means half multiplied by 2 pi, which is just pi radians. It has just done pi radians. So how much is the length that it has traveled? R into that particular angle. R is how much? 60 multiplied by just pi. Great. But the question is, you have to find the value of x, which is that extra distance which the second hand will go. Second hand will go faster so many times. So it has traveled extra distance. So that x will be L1 minus L2. L1 will be 75 multiplied by 30 multiplied by 2 pi minus 60 pi. 30 into 2 pi is 60 pi only. So 60 pi will come as common, and I will have 75 minus 1, which is 74. So 60 multiplied by 74 pi. Okay. So that is in centimeters, but the question is in meters. So if this is in centimeters, you will have to take this 60 multiplied by 74 pi, but pi also you'll have to substitute as 3.14. Whole thing divided by 100, that answer will be in meters. So solve this and see if your answer comes out as 139. Okay, that's the same thing which we have done. Okay, so you should get the answer as 139 meters. Okay, got it? So this was asked. So just based on the length of the arc concept, which we have just done over here. Length of the arc is r into theta. Okay, great. Now let us go to the concept of centripetal acceleration and uniform circular motion and all of that. Okay, because that is the last part of today's class, uniform circular motion and also the concept of tangential acceleration and all of that. If you ask me what is uniform circular motion in simple words, I can give you examples like the second hand of a clock or the rotation of moon around the earth or even the minute hand or the hour hand of a clock. All these are uniform circular motions. Which is non-uniform circular motion? When I turn on the fan in my room, slowly the speed changes. Or when I turn it off, slowly again the speed reduces. Or the wheel of a bus, increasing speed, decreasing speed. That is non-uniform circular motion. So what is special in uniform circular motion is that if you take some seconds and you see how much angle it has moved, in that same seconds ahead, it will move the same angle. So it moves equal angles in equal intervals of time. So equal intervals of time, it moves same angle. That is UCM. Non-uniform is in 1 second if it moves this much, next 1 second it will move this much, next 1 second it might move only this much. So angles covered are different. So uniform circular motion. So in uniform circular motion, it covers, you cover equal angles in equal time intervals. Equal time intervals. So my speed is definitely a constant. My speed is definitely a constant. That means magnitude of the velocity. But keep in mind, this is very important, but V bar, which is velocity, changes in direction. Changes in direction. So as a vector, it is not constant. Changes in direction. So vector wise, it is not constant. Vector wise, it is not constant. Similarly, if you ask me, omega, omega always remains same. It is always going to be up. As it revolves, the vector will be always up. So omega is going to be constant because it covers equal angles in equal time intervals. Omega is angle by time, equal angle, equal time. So omega is constant even vector wise. Okay, it is always going to be constant in vector. It will not change in length, nor will it change in direction. This is very, very important regarding uniform circular motion. Okay, till this point, absolutely clear what is the meaning of uniform circular motion. I can give you examples also over here. So example, the hands of a clock, hands of a clock, right? Or the motion of moon. It is periodic, it revolves with constant speed, almost approximate motion of moon. It might change because of the gravitational pull and all of that, and some elliptical orbits, but almost it is uniform circular motion for all practical purpose. Now, there are certain parameters of a circular motion, uniform circular motion, which you should know. One thing is the time period. T is called the time period of uniform circular motion. And we all know frequency. This frequency is related to the time period by 1 by t. Very, very important relationship. Frequency is 1 divided by the time period. Frequency is 1 divided by the time period. Oh yes, somebody also pointed out, what about alpha, sir? Yes, because omega is constant, also alpha will be 0. No angular acceleration. There is no absolute need for any kind of acceleration. So alpha is angular acceleration, which is not there at all because omega is constant. Correct. Good. You pointed it out. So frequency is 1 by time period. Next thing, omega, since it is delta theta by delta t, imagine if I take one rotation, for one rotation, the time will be t. For one rotation, that angle covered will be 2 pi radian. So, can I not say for uniform circular motion, delta theta will be 2 pi, time will be just 1 by t, or time will be just time period. So, omega is 2 pi by t, but also 1 by t is f. So, hence, it is also 2 pi f. The same thing I had given it to you over here also. Omega is 2 pi f. Where did it go? Where did it go? Omega is 2 pi f. See, right over here. It's just I'm adding one extra thing, which is 2 pi by time period, which is also very, very important. Okay. So, yes. Dun, 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 dun. Where are we? Where are we? Yes, omega is this. Okay. So, I'm just going to block this off for you. Simple, easy peasy, right? So that is uniform circular motion. Just to give you some examples on this, imagine I tell you, if the frequency is 20 hertz, find time period and omega. Find time period and omega. Let's do this. Very straightforward. Frequency is given, find time period and omega. Okay, what do we do? Time period I know is 1 by f. So it is just 1 by 20. 1 by 2 is 0.5. So this will be 0.05 seconds. So that is the time period, done and dusted. Next, find omega. Omega is 2 pi f. So it will be 2 pi into frequency, which is 20. So it will be 40 pi radian per second. That is your omega. Cool? Very good. Let's do one more question coming up on your screen, and here it is. See, the question says velocity is 40 pi meters per second. Radius is 2 meters. Find frequency and time period. Find the frequency as well as the time period. Let's think about it. How do we go? Frequency and time period, if I need omega. So to find omega from velocity and r, I think there is a relationship. Velocity is omega r. Velocity is 40 pi. Radius is 2. So from this, omega is 20 pi radian per second. 20 pi radian per second. This much is clear? Omega is 20 pi radian per second. Great. Once I get omega, we can easily figure out f and t. First of all, to find frequency, omega, remember, is 2 pi f. Therefore, f is omega divided by 2 pi. That means it is 20 pi divided by 2 pi, which is pi goes. So it will be just 10 hertz. For finding time period from omega directly, omega is 2 pi by time period. Therefore, t will be 2 pi divided by omega. So 2 pi as it is, omega which is 20 pi below. So it will be 1 by 10, which is 0.1 second. So everything we figured it out. Okay. So these kind of simple dimple questions you can get, where very rare to get such easy questions, but this gives you an understanding of all these formulas. Or else if I go to a direct good question, you'll be like, sir, wait a minute, I forgot the formula, what was the formula, etc. So that is why these basic questions you should know on these things. Uniform circular motion. Okay. Now let's come to the main critical part, which is the acceleration in a circular motion. And there are two kinds of acceleration which you have in a circular motion, and that is what we are going to talk about. Okay, let's go about it. Starting off with first one, which is called centripetal acceleration. Now, why will there be something called a centripetal acceleration, and what is the meaning of this? Let's understand. See, if there is a particle and it is going in a straight path with constant velocity, obviously the acceleration will not be there at all. There is no reason for it to accelerate. But imagine there is a particle which is going in a curved path, but the speed is the same speed. And I've asked this question many people. Sometimes they give wrong answers, sometimes they give correct answer. I ask them, is it accelerating? It's going in a curved path. Now tell me, if the speed is same, okay? Here also the speed is same, here also the speed is same, here also the speed is same. Constant speed it is going. Is it accelerating? A lot of people say, sir, same speed. No, sir, no acceleration. Wrong. Acceleration is rate of change of velocity. And velocity can change if direction changes or magnitude changes or both change. Here, the direction is changing. It is going here, then here, then here, then here. So if direction changes, the vector changes. If anything changes, that's it. It is changing. So it is accelerating. So even though the speed is same, the direction is changing, or the direction changes. Therefore, it is accelerating. It is accelerating. But then the question arises, if it is accelerating, which direction, sir, it is accelerating? Is it accelerating like this? No, it won't accelerate along the path, because if imagine the path is like this, and if acceleration is along the path, then here if the speed is 2, here the speed will become 3, then 4, then 5. Speed should not change. So acceleration should have no role to play in the magnitude of the velocity. If velocity was this much, it should stay that much. If by chance there is some acceleration here, it will immediately increase the velocity. If velocity was this much, acceleration is like this, it will reduce the velocity. The only way it cannot change it is if the acceleration is perpendicular to it. If acceleration is perpendicular to it. So this has acceleration, but the acceleration is perpendicular to the velocity. Acceleration is perpendicular to the velocity, and it is only responsible for changing the direction, not the speed or the magnitude. Got it? Yeah, it is not angular acceleration, it is linear acceleration that I'm talking about. And if you now just imagine, where will all these accelerations meet? Where will all these accelerations meet? It is quite evident they will all meet at the center of the circular path. Since these acceleration, the acceleration that changes direction only is directed towards the center of the circular path, towards the center of the circular path, it is given a special name. It is called as centri, because towards the center. Petal means towards acceleration, and the symbol for it is A with a subscript of C. It's a vector, so put a bar. So that is called centripetal. Petal means towards the center. So that is why centripetal acceleration. And what does it do? It is only responsible to change the direction alone. Everybody clear? So in a uniform circular motion, will it have acceleration? If that question comes, what will you say? In uniform circular motion, does it have acceleration? The answer is yes. The acceleration is there. In fact, it is only the centripetal acceleration which is there, and which is definitely not zero. Centripetal acceleration is definitely there. Got it? Yes, perfecto. So, how much is the value of the centripetal acceleration? There is a derivation for it. Let's not worry about it. AC is nothing but angular speed square into R. But if you want omega, we can write, since V is omega into R, therefore omega is V by R. Therefore, AC will be, instead of omega, you put V by R square into R. So it will become V square R by R square. So it will become V square by R. You can also write it as V square divided by the radius. So either of the two formulas you can use. For finding centripetal acceleration. Very simple and straightforward. Cool? That is uniform circular motion. Okay. So let's do some questions on that. If in a uniform circular motion of 40 hertz and radius 0.1 meter, find the centripetal acceleration. Question is, find the centripetal acceleration. Let's try this out. To find centripetal, we'll need either velocity or omega and then radius. Radius is given. I think we can find omega because this is nothing but frequency. Therefore, omega is 2 pi into f. So 2 pi multiplied by 40, which is 80 pi radians per second. Great. So now we'll find centripetal acceleration, which is nothing but omega square r. Omega is 80. So 80 pi square into radius, which is 0.1. 8 square is 64. So 6400 pi square multiplied by 0.1. So it will become 640 pi square meters per second square. That is your centripetal acceleration. Yes, it is valid for all circular motions. Even non-uniform circular motion will have centripetal because, it will have directional change. So wherever the direction changes, it is bound to have centripetal acceleration. Okay, let's do the next question coming up on your screen, and here it is. A man is carrying a monkey on his shoulder and does cycling. Why would a person do that? I think only in physics problems, and that too JEE. Some NTA person only is doing this. That NTA person is carrying a monkey on his shoulder while cycling. Wow, very good. And the circle's radius is 9 meters and completes 120 revolutions in 3 minutes. The magnitude of centripetal acceleration is. So, radius is known, revolutions per minute is known. So, I think we can find omega first. So, omega will be, let's think, 120 revolutions in 3 minutes. That means 120. Each revolution is 2 pi radian, and there is 3 minutes. That means 3 into 60 seconds. So that will be okay. Uh, 3 goes with, let me just do it, not just mentally. 3 will go with 120 40 times. 0 and 0 will cancel. 2 will go with this 3 times. Yeah, perfect. So we are left with 4 pi by 3, 4 pi by 3 radian per second. Okay. Next, we have to find centripetal acceleration. That is omega square r. Omega is 4 pi by 3 square into radius. Where is it? 9. Okay. So this will be 16 pi square multiplied by 9. 3 square is also 9. 9 goes. So 16 pi square, but this will be meters per second square. That is the answer. So 16 pi square meters per second square. Is this absolutely clear how we figured it out? Everyone? Perfecto? Yeah. So these kind of questions have come in J. All right. Let's do one more question, guys, coming up on your screen. And here it is. Okay. Let's see if we can do it. An object moves at a constant speed along a circular path, horizontal plane with the center at the origin. When object is at +2, velocity is this much. When the object is at velocity, the acceleration at x equals to -2 will be how much? Velocity and acceleration. Okay, let's draw it without drawing. I don't think we can visualize it. So this is x and y axis for us. The particle is going in a circular path. So let me draw that circle. It is like this with the center at the origin. Okay, perfect. When the object is at x equals to +2. So this is x equals to +2. Then it is known to me the velocity is -4 j cap. That means it is downwards. The velocity is -4 j cap. Is -4 j cap. Okay, it is downwards. That means the circular motion is in this direction, clockwise, not anti-clockwise. So that confirms by the velocity's direction. What is the velocity and acceleration at x equals to -2? X equals to -2 is here. This point is x equals to -2. So it's quite obvious the velocity will be in this direction. Same speed. So velocity here should be +4 j cap. +4 j cap is here, not here, not here, not here. So it should be option 2 and without even checking the other option. So hence that is correct. But let's say there were 2 options with 4 j cap. Then what to do? Then we are bound to solve the next part. Here, the acceleration will be directed towards the center. Here, the acceleration will be again directed towards the center. Okay. So this is the first case. This is the second case. Can we figure out the magnitude of it? I think so. Remember, this acceleration is nothing but centripetal. It will be nothing but v square by r. What is velocity? Magnitude wise, it is 4. What is radius? It is 2. So 4 square is 16 by 2, which is nothing but 8 meters per second square. But if you ask me vector wise, this is towards the I cap direction. So it will be 8 I cap, which is right over here. 8 I cap meters per second square. Clear? Right. Kushal, you'll have to sleep less. You have to give up on luxuries. You have to find time between breaks, between travel, while traveling. You have to minimize your travel and unnecessary social distractions. You have to do school chapters and JEE chapters together, not separately. You have to, you know, not watch or not attend something which is not important, like any some random activities there in the school. Try to keep your school attendance minimum. Try not to attend any party, function, anything at your house. Keep your place very sacred wherever you are studying. Don't let anyone disturb you. Turn off all the notifications. Just do that. You will see, you will find double, triple the time that you're getting right now. Yeah, great. Let's go to the last one in the non-uniform circular motion. Now, I just told you that if you are going in a straight path with constant velocity, then my acceleration is zero. But let's say I'm going in a straight path and my velocity is not constant, then immediately I will tell I have some acceleration. Also, I saw if my speed is constant but direction alone is changing, speed is constant. So speed is constant, but velocity is not constant. Then we saw that in that case, you are accelerating towards the center. You are accelerating towards the center. Your acceleration is the centripetal acceleration. That is what we saw. Now comes the worst of the worst case. What is that worst of that worst case, guys? Imagine you are going in a circular path or changing direction, but your velocity is not constant, speed is not constant. Like this, then after some time your velocity is even more. After some time your velocity is even more. Then what do you think will happen? Your speed itself is not constant. Then obviously you will not only have your centripetal acceleration to will be there, no doubt, but because your speed is changing, there will be another acceleration along the tangent. There will be another acceleration along the tangent of the path drawn. That is called tangential acceleration. So the path, if you draw a tangent, the speed is changing. So there is a tangential acceleration responsible for changing the speed, not direction. Okay, so that is the concept of non-uniform circular motion, my dear warriors. So you will have tangential acceleration. So A subscript T is nothing but the tangential acceleration, that changes that changes speed. And this tangential acceleration, you will see, is parallel or anti-parallel to the velocity. So if AT is in the same direction as that of velocity, then you will notice that the speed will increase. Then you will notice that the speed increases, but in some situations, your acceleration tangentially might be opposite to the velocity. In such cases, your speed will reduce. Speed reduces. That's it. That's the only difference. It's common sense. Acceleration, velocity, same direction, it will increase. Opposite direction, it will reduce. Okay, very, very important. This tangential acceleration is then dv bar mod by dt. Very, very important, guys. It is rate of change of speed because it only changes the speed, linear speed. So A tangential is dv bar by dt mod of velocity inside, not outside, it is inside. Keep in mind. Very, very important. That's the formal definition of tangential acceleration. If you ask me, is there a formula between angular acceleration and tangential acceleration? The answer is yes. We can figure that out. See, we just saw some time back, my velocity is r omega, isn't it? How about taking derivatives on both sides? Because actually speaking, this v is nothing but v bars mod. This is nothing but r into omega. So take derivative d by dt of the speed. R is a constant, so it will be nothing but d omega by dt. This term I just told you is nothing but tangential acceleration. So A tangential will be r. What is d omega by dt? It is nothing but alpha. A tangential is r into alpha. Very important. L is r theta, V is r omega, A tangential is r alpha. All three formulas done. So now I know the formula for tangential acceleration also. I know the formula for centripetal acceleration also. A centripetal is this much, A tangential is that much. Very, very important formulas. Okay, everyone clear till this point? So now you might be wondering, sir, if there is a non-uniform circular motion, it has tangential acceleration, it also has centripetal, won't it have total acceleration? You are absolutely correct. I mean, tangential acceleration will be in one direction, centripetal will be in one direction, the resultant will give me the net acceleration. So that net acceleration A is simply the vector sum of centripetal and tangential. Magnitude wise, if you ask me, it is nothing but Pythagoras theorem if you use AC square plus AT square, because they just form perfect right angled triangle. That's it. You can see it right over here. Yeah. This, if it is AC, this will be AT. And of course, this will be the net acceleration. That will be A over A. So it's a Pythagorean triplet. AC, A tangential here also you can put. Hypotenuse will be total acceleration. This is the magnitude part of it. So keep this in mind, very, very important. And now I can say the total acceleration is dv bar by dt. This is rate of change of velocity. Rate of change of velocity. When I write at and just I put dv bar mod by dt, it is rate of change of speed. Rate of change of speed alone, which comes out as alpha into r. And when I write AC, it is the acceleration due to directional change. It is acceleration due to change in direction. And that was v square by r, or omega square r, or omega square into r. So this tells you clear-cut distinction between centripetal, tangential, and total acceleration. Correct? Yes. This is vector form. Yeah, this is vector. So these are just the magnitudes. A tangential is always parallel to the velocity. If you know the velocity's direction, you know the tangential acceleration's direction. Centripetal will be perpendicular to the velocity. Simple. Okay? As simple as that. So A tangential vector wise, if you ask me, AT vector, that will be whatever R alpha is, but just put V hat. Why V hat? Because wherever velocity is, same direction. So along that tangent. So that is why you can put V hat also. Okay, it's one way of looking at it. One easy way of looking at it. Great. So that was there in the theory and every application that we have seen. Although tangential acceleration, I have not done much questions now. I'll be doing it in the third lecture where we deal exclusively with vertical circular motion coupled with some crazy problems and all of that. Okay. So for now, this much is enough. Next lecture, we'll just do centripetal force and centrifugal force. That's it. Okay. That's all we are going to focus on. Okay. I hope you enjoyed the class. Have a great time. Take care. Bye bye. Hasta la vista. Captain Shreyas signing off.